Nathan has been interested in console hacking since he was very young. Around 2007, he got his hands on a PSP and has never let go of it until this day. One day, we might really get our very own Metal Zig Solid pointer walker game. But to build a world without architecture and API borders, we first need to create a language to surpass C++. And I think we might have. The talk is Zig on the PSP. Nathan, this room is yours.
Hello, thank you, Christoph. It's a pleasure to be here. So my talk is Zig on the PSP, how I learned Zig and I learned to love it. So really quick, who am I? I tend to ask myself this a lot. My name is Nathan Bourgeois. I recently turned 19 over the summer. I'm studying at The Ohio State University for Computer Science and Education. I've been a programmer since about grade 5, which means that technically I've been programming for a decade, and wow, I really start to feel old now. I run a YouTube channel at youtube.com/iridescence. I do a lot of programming, PSP hacking, and overall just some pretty cool content. And I am a PSP homebrew developer. So, of course, the main subject of this talk is the Sony PSP or the PlayStation Portable. Now, I think we would consider it a retro console, even though sadly it doesn't feel that old to me. It's incredibly powerful for what it was at the time, featuring two MIPS R4000 based processors at 333 megahertz, a vector floating point unit at 166 megahertz, capable of doing vector and matrix operations at much faster speeds than by CPU. And it also features the GPU running at the same frequency. It has 32 to 64 megabytes of RAM, and you can cram in up to however many gigabytes of storage your SD card can fit. So, why would you make homebrew in the first place? Well, number one, I think it's really fun to do um, because, hey, it's an old console. It's something that maybe you had during your childhood or sometime during your early adulthood. And it's something that's really just a fun sort of topic to mess around with. You can go ahead, create these little apps, and you can just have some nostalgia for the device. The second thing is that it's actually kind of challenging, namely because you have restraints. You have restraints and constrictions placed upon you. The CPU isn't necessarily the greatest thing in the world. You don't have infinite amounts of RAM. You don't have, the shiny new RTX 3090 sitting in your computer there to go ahead and render the state of the art graphics. Um, and you really have to start working and thinking outside of the box to go ahead and accomplish whatever goal you have. Another reason I think that's kind of growing is that we have a community. We have a Discord server about 3,000 people, and personally, I have a community of about 1,250 people. There are a lot of people who are still interested in making homebrew games and doing stuff like that, and it's really fun to talk to various people around the world about just developing for this console. I think, in my opinion, it's sort of the sweet spot of specifications. It's not like too restrictive to where everything needs to be written in pure assembly, but it's also not too forgiving, as in you can't just assume that your latest ray tracing program is going to work on it just fine. It's very open and well known. The PSP has been, basically hacked and exploited and reverse engineered for so many years now that we practically know a large portion of what you need to know about the PSP, its OS, and a lot of its protocols. And finally, creative problems and solutions. On hardware like this, you're gonna obviously encounter some errors that you just never would think to expect on, a modern PC or ARM. You're gonna have some weird case where, oh, you're writing to the data cache and that doesn't make any sense, and you're getting garbage data and all of these different things, and you have to create different solutions to these problems. Make sure that you're checking everything, and make sure that you're writing good code. So, where was the Zig? Earlier in this year, the project called Rust for the PSP was born, and it showed that LLVM had a place. And what I mean by this is that previously, before this language showed up, pretty much there was no sort of LLVM support. There was some experimental support way back in 2011, 2012 that was removed for quite a while now. And basically everyone had just accepted their fate and used GCC and C or C++. With Rust PSP and some pretty much stock LLVM, basically we could go ahead and create apps with LLVM, and it really started to work and show that any LLVM language could probably work on the PSP. So I was inspired by Rust and obviously Andrew's talks about Zig. Basically, I had watched a lot of his presentations at conferences and stuff throughout the earlier portion of the year. I was really interested in starting a journey on Zig. So I decided to start my journey on July 31st, 2020, on a live stream. It's still live. It's 3 hours of me just trying to figure out how do I even use this language. So how did that go? It was kind of like tripping on a landmine, getting thrown into the air, and somehow executing a not so perfect backflip. It was very hacky to say the least, with some Rust tools, maybe a cryptic looking bash script, some linker wizardry, a few bits of assembly and C sprinkled in, and somehow it ended up working. We got an application that booted on the PSP that was written with Zig and compiled with Zig. So obviously, we have to go somewhere further with this now that we know that it actually works on the PSP. Basically, we had to add some common utilities. For example, printing to the screen. Actually being able to see that your code is doing something is generally a very good idea. So adding text printing, stuff like that. Um, Alongside of allocating memory, which might be important if you actually intend to have an application that isn't pre-allocated. Alongside having the home button, because without having the home button enabled, if you don't know, if you press the home button in a PSP game, it brings up a little menu that allows you to exit the game. Without that, you're kind of stuck in the water, and you have to like hard reset your PSP, which just takes forever because you have to pull out the battery, put it back in, turn on the system, and then get back into whatever you were doing previously. Another important thing was adding all of the system libraries, so the libraries that are given by the PSP OS to the user for them to make applications. That's pretty important if you're going to make an application. Using some Zig only tools. So, for example, I don't want to have make the end user have to, install Rust or install the old toolchain. By the way, the old toolchain still can take up to 2 hours to install. So definitely making some Zig only tools would really help that. I wanted no dependency on Rust just as a general self hosting thing. And I wanted to have some efficient and effective code with some Zig specific features and some safety. So, Zig PSP tools. In order to generate a valid working executable for the PSP, you need a PRX, an SFO, and a PBP file. Now, that might mean a whole lot of alphabet soup, but let's go ahead and walk through it. An SFO is basically a descriptor of an application or a save file, and it's a key value map. It starts with a sort of header section that tells you where the keys are and where the values are, and then the length of each one, the alignment and padding and stuff like that. And then basically it tells you all of these different keys. Once you parse these keys, they have different meanings. For example, what's the title of your application? What is, the minimum firmware version that you need to be on to run it? Stuff like that. Really basic sort of properties that you need. Furthermore, then you need a PBP file, which is basically a packed binary file. It's essentially an archive with a header on top that tells you where each file is located in the file. So it's an archive that's not compressed. Basically, it has like the background image if you want one, like the icon of your program if you want one. It has to include the SFO and it has to include the PRX executable. PRX is basically a portable, relocatable executable because we need to start EX with X. It's basically a very special type of ELF file with some custom MIPS and custom Sony stuff inside of it. Right now, that tool is actually still in C, but the rest is in Zig. So for the SFO tool, basically you can go ahead and write these SFO files and read these SFO files. You can also take it from a JSON file, which is something new, and basically it allows you to much easier uh, modify it than having to enter in a bunch of command line arguments. For the PVP file, it basically can pack and unpack these PVP files. So for the PSP OS APIs, it's really important for any homebrew game or any general purpose application to have access to the OS API in general to make anything. Basically, you need to have small and efficient wrappers around this sort of thing, and you have to be able to make it basically functional for the end user. Uh, One of the problems that was encountered with the initial Rust adaptation, it's fixed now, by the way, but was that wrapper size was very huge because of some strange issues with ABI mapping. So the modules, basically each sort of little library that you want to include, every driver, as you could say, would basically be its own module. These modules start with the EABI call. These modules have functions inside of them, which have the EABI calling convention, which LLVM isn't using. It uses O32 instead. And then basically you need module support for import structures. And what that means is that basically to have your functions imported, you have to generate a stub method, and then have an information structure of what functions that you are importing. And basically, you put this inside of your ELF file, and then the program loader decides to try to resolve these and do that. And the function IDs are NIDs or named identifiers. They're basically a SHA-256 hash of the function name, and it's the first several bytes of that for which functions that you're trying to include. So, doing it the Zig way, how did we generate this? So we generated these structures using compile time global assembly, and by doing compile time global assembly, we were actually using these assembly code generator sort of macros. So they're basically stitching together some pre-known information and putting it into a full assembly file, and then having Zig the compiler decide to compile it. Uh, this way, we could have them all in their different files for each different module, and then basically each one would be lazy analyzed, meaning that you're only importing what you actually need in your application. Furthermore, for the ABI clashing issue between EABI and O32, basically there was a comp time ABI wrapper that I made. It was pretty cool. Basically, you take in a variable number of arguments and then give a stub, and then basically it will call it with those arguments instead of the actual function being called with uh, O32 when it's supposed to be EABI. So this way, it's a soft wrapper around it that just lets you have these functions that will work. And it's critical for a lot of the standard OS functions that have more than four arguments for this to happen. So what does a hello world look like? So right here is the basics of a hello world. Basically, you say const PSP equals import PSP utils PSP.zig. You could actually do this multiple ways. There's different ways to import certain modules, but you're going to generally need a few certain modules that are grouped up in PSP.zig. Basically, you want to run a comp time global assembly block with the PSP module info macro to generate some of the module information, which is needed for your application to actually be run. So the first argument is the title. Then the next one is whether it's a kernel mode or user mode PRX or module. Basically, right now we're not running anything in kernel mode, so it's all in user mode. And then the next one is the major and minor version of your application. Finally, we have pubfin main, and then you can have the type after that. This does support error set or error union types with a default error handler. Inside of this block, then we have PSP utils enabled the home button callback. That's what that stands short for, so that you can actually exit the application if you want. And then you run screen init, and then you go ahead and print hello from Zig onto the screen. Now let's go ahead and actually take a look at the example. I'm going to be running it through an emulator, but this is the same exact example here. Slightly different spacing because I need to fit it on the slide. And if we go ahead and just run zig build, it goes ahead and builds the entire thing. We can go ahead and run the eboot.pbp file in a PSP emulator. And as you see, it says hello from Zig out onto the screen. So switching back here. So what were some of the results? Well, the code is tiny. It's actually really small. It's smaller than the default C example by about 91%. Zig build does everything for you, and it doesn't necessarily have any complicated make files, any weird build scripts, anything like that. And it also supports complete user mode functionality. As you can see by the screenshots below, the PBP tool tells us that we have an application size of 6,842 bytes, and the GCC default is about 68,000 bytes. So we're 90% smaller than that, which is a really good improvement on the GCC toolchain. Furthermore, let's go ahead and take a look at some more of these examples and how we're actually going to be doing it for most user mode applications. For a lot of the user mode applications, you want to go ahead and just git clone, and then we're going to go https github.com/zpsp-dev zig PSP template. And this downloads an entire template. You're going to need the recursive flag because it does include submodules for every tool. So just doing this, we go into Zig PSP. It generates all that. Go into the Zig PSP template, and we can just go ahead and run Zig build. And that's all that it takes to start a Zig application. It compiles all of the tools that you need. It compiles the SFO generator, the PBP tool, the PRX generator, and then it can also compile your application with it. And as you guys can see, we actually have it completely built. So that was pretty simple. So what else can the toolchain do? If we want to go ahead and open up some of these examples over here, we can go ahead and take a look at maybe let's do some allocation support. So allocation support. It's going to build, and it builds really quickly, by the way. Basically, now we can track the number of bytes. What we're doing in here is that we're basically going to go ahead and create a string from these different sections here. So hello from Zig, each one. So we're going to allocate that and use an allocate print. And then we're going to go ahead and free it afterwards. So we go ahead and this is before everything. We print it out after we allocate it. So what we have left after we allocate is this many bytes, and then we go ahead and free those bytes, and then there we go. We're at the end of the application. Furthermore, this supports panics. So basically, if something goes wrong, everything panics. Let me just check that we're in release safe. We should be in release safe. Okay, so now that we're in release safe, we're going to go ahead and build this application with panic support. Panic support is just pubconst panic, PSP debug panic. Then we're going to go ahead and run it, and it's going to say the PSP has panicked. Reason for an integer overflow, because our function here is add 1 to 255, which, as you know, causes an integer overflow. So we have safety through that. We also have pancake mode, which says the PSP has pancaked. Furthermore, let's go ahead and go and view a more impressive example, which is the cube example. Right here is pretty much written in the entire PSP graphics utility. It allows us to set up a 3D context. What it does is pretty much sets up pretty much basically OpenGL 1.3 like interface, and you just have to go ahead and submit vertices to it. And if we go ahead and build it, we're embedding our texture inside the file, by the way. We're going to go ahead and run it. And as you can see, we have our Ziggy the Ziguana basically on the cube, and it's going ahead and rotating. Oops. So what's been added since that? Everything that was just demoed was version 0.4 of the toolchain. Pretty much after this, we've added this the standard library, bring your own OS layer. It's kind of a work in progress. Of course, it's going to be a work in progress for a little while. It supports basic input output and most of the standard file system library. So you can create files, you can open them, you can write to them, you can delete them. You can go ahead and create and delete directories as well. And it also includes some other utilities for such as printing with stt.debug.warn to the PSP's standard output or standard error. It also includes the time.zig sort of implementation due to the fact that some of the code is not necessarily completely compatible. We've also added a safe wrapper for the C API, so it's a small wrapper on top that catches errors and things like that, and sends them as actual errors to Zig. And then we also have pretty much that's all that we've added in version 0.5. It includes some of the documentation as well. And Zig PSP's version 0.5 released about 10 hours ago. So it's actually up and ready for you to go ahead and use as soon as you want to. So some of the things that are planned to be added in the future are a compile time VFPU assembler with proper parsing. So tapping into the VFPU, which is majorly faster than a lot of different things on the PSP. It's pretty much faster than the main FPU in most operations by up to 40 times faster, depending on what sort of data you're doing. So it would be really useful to have a compile time assembler that would basically do that for you. It would essentially just have to translate your VFPU opcodes into the correct basic instructions that you're going to be submitting. I also want to add support for the custom Allegrex instructions because not all of them are uh, basically added, and Allegrex is the name of the PSP's processor. Also, want to add support for plugins. Plugins are sort of a feature that allow you to run a custom PureX module at any time. So, for example, in the main PSP OS, it could be during a game, it could be during emulation of the PS1 as well. So, there's different times that you can use plugins, and I'd love to add some of that support into the PSP. I also want to go ahead and make full documentation, and what I mean by that is generating it through the Zig document generator, as you can see with stuff like Lola and the standard library, of course. I'd also love to add kernel mode programming. It would be a cool feature, definitely to add. Uh, I do have to warn you, don't mess around with kernel mode because you can really break things if you really try. Um, yeah, just be very careful that you don't turn your PSP into a brick. Uh, Another thing that I want to add is encrypted PRXs, which would be just a PRX signing tool. This already exists, and I'm pretty sure it would just work from the main GCC toolchain. But you never know; there might be still some differences between how that works. I'm pretty sure, though, that that tool can actually still be used to sign PRXs right now. And then furthermore, I want to finish, as I said earlier, that PRX generator in Zig, because it would be very good to have a fully Zig toolchain. So PSP projects that are currently or in the future going to use Zig. Craft Server, which is a cross-platform Minecraft server. It's one of my personal projects. Currently, the status of that is that it's compatible with Java Edition 1.15.2. It has basically it has a login system already. You can send chunk data and you can send light data. You can also do chat and stuff like that. It also has handlers for movement. So it's actually at a pretty good state so far, and it just needs to backport it over to the PSP. The next thing is the Game Jam engine, which is a very generic name for a very generic game engine. It's something that I've been working on for a little bit now, and I'm preparing to do a demo for it next week, hopefully. And it's to be used in the Community Game Jam, which I'll talk about later. And then finally, Project Dawn, which is going to be sort of a big project that I want to take on, which would be doing sort of a new OS and UI system. It would include a lot of new and modern UI design alongside with newer features for the PSP, like, for example, having multitasking apps for once. That would be something really nice. And maybe some nice modernizations and ease of use for programming. Not all of it will necessarily be in Zig, but I hope that most of it can be done with either Zig or Clang together, working together. So I'm going to go ahead and ask you guys if you have any questions. Below here are the links. The first one is to the overall project. The second one is to the project template. Then the next one is to my YouTube channel, and the last one is to our Discord server.
Thank you very much. That was awesome. So I think we have already a couple of questions, but I'll give a moment to chat to think of other questions and type them up in chat. In the meantime, I'll just as a quick reminder to ask a question, you can type it in chat on Twitch. Maybe try to tag me so I won't miss it. But at the same time, if you are on IRC or on Discord, you can also write your question there, and I'll be able to find it and relay it if you need it. If you want me to, sorry. Okay, so in the meantime, let's see. So that was really something. So I want to ask you how you discovered Zig, because you pretty much answered that during your presentation, right? You discovered it while hacking on the PSP, while live streaming also, which is awesome. And yeah, I think that I think it's really interesting. Maybe it's not for everybody to watch like a 3 hour long video, but if you're curious to
Definitely.
see if you're curious to see the mental process of somebody going through something the first time, and I think it's interesting. I occasionally do watch long videos like that. Maybe not all in one sitting, but yeah, I think it can be entertaining.
Okay.
So let me start with. So let's see. There was a question from before. Poro Porosion Porosion. Well, anyway, sorry, I'm awful at pronouncing nicknames. But the question is, I'm coming from the Nintendo DS scene. Is there any
All right.
document like GBA tech for the PSP documenting the entire hardware?
All right. Okay, that's actually a very relevant topic. So one of the things I do is PSP tutorials and stuff like that. And right now we're working on basically revamping our wiki. Our previous wiki went down, so we started a new one. And basically, I've been working on getting a lot of articles on there for different sort of things. Right now, it's kind of at a basic stage of just install the toolchain, how that stuff sort of works. But I want to go ahead and work more on that. As an individual and as a community in general. I know that there are a lot of people who are interested in that sort of thing, and I think we're still making an effort to try to get more people into the scene. Another thing is that the original C documentation has quite a lot of useful information if you're into reading technical documents.
Okay, still from the same user, another question is about the size comparison between what you get from Zig build and what you get from compiling with with the GCC toolchain. The question is, does the GCC toolchain use flags such as function sections, data sections, WI, GC sections, LTO? I'm guessing these are all flags that end up producing the size of the final executable.
The GCC toolchain, from what I know, doesn't use function sections. I could be wrong about that, but I don't believe it uses function sections. And then it also, I believe, doesn't do LTO yet. I think you can probably do it, and I think that there are definitely ways to reduce the size, but I'm trying to compare it in the sense that what is the default output between the two? You definitely can massage your code to be very, very small. I've seen that happen before, and I've seen people do that, so I know that it is possible to definitely get code as small as this as well. That being said, I'd also like to say that the C standard library is what takes up almost the majority of the executable. And some of the things can't necessarily be just completely garbage collected out of the main. Com- a lot of the things can't necessarily just be, dead code stripped away from the main GCC toolchain, mainly due to the fact that for some things such as function data and stuff like that, it needs to be preserved in order for the application to work correctly. So in that sense, it's kind of a logistical issue.
Hmm. Uh, so another question from me. Maybe we can also give some information to Poro um, from the point of view of Zig. But before that, do you link with libc in from the Zig version?
From the Zig version, we do not link with libc. mainly because it adds a lot of extra weight that isn't necessary.
Mhm. Okay, thank you. So I wasn't aware of, I wasn't sure about that detail, but then maybe I can also say something to borrow. So the idea is that from in Zig we don't strictly depend on libc, but the Zig can depend also on other libraries like other implementations like Muscle. And in general, also another point is LTO. For example, in Zig there is no LTO step because everything gets compiled at a single compilation unit before getting to the linking stage. So there are a few assumptions that don't hold in the Zig ecosystem. And if you're interested, you might want to look into that a little bit more. Maybe they might provide other interesting properties for what you are trying to achieve, which in this case, for example, a small binary size ends up being something quite useful. Let's see, another question from Nipsey. Is the SDK limited to a certain generation of PSPs, or does it work for any PSP?
It works for any PSP. Pretty much, it's all cross compatible because basically all of the functions are the same on every single PSP. You do need a custom firmware on your PSP, but that's been something that's been true for the last 10 or 11 years. So basically everything is cross compatible no matter what version of PSP you have. The memory size is different between the 1000s and any generation higher. And this is the original 1000, by the way. The new E1000 and N1000 ones are 64 megabytes. So there isn't any functional difference between the two. There are some very minute changes inside of some of the kernel libraries, but not necessarily exposed to the user.
Awesome, thank you. Let me see. So, d- uh, it's a bit too early for that, I guess. But do you think you seen some of the work done for the self-hosted compiler? Do you think you would get some advantage in maybe in the future implementing some of the functionalities that you offer through the SDK as like a new target for the Zig compiler?
I can't quite comment on that. I don't necessarily have enough information on how that sort of thing would work. One thing that I think would be pretty cool would be if there was a way to, count references to a function, to an extern function in this case, because by doing that, we could go ahead and specifically count with module imports what functions we exactly precisely need. And in some cases, that can be uh, up to 50% less code size taken up as well.
Okay.
Currently, the only way that I can really estimate that that would be possible would probably be with an external tool.
Mm-hmm. Mm-hmm. Understood. Um, okay. I think that was it in terms of questions. Let me double check that I'm not missing uh, anything. Let's see. People in voice. No. Okay, we should be good. So before we move forward, is there anything else you want to say?
Yes. For one thing, one last thing, if you're interested, the PSP homebrew community is in fact having a Halloween game jam, and in this game jam, we're going to be making sort of Halloween themed games. It starts on October 23rd and lasts through October 30th. It's a 7-day game jam. The winner will be announced on Halloween itself, and you can use any language and any engine. You can actually start building your engine ahead of time. You don't have to build it at the start of the jam, and it's pretty much just a jam for fun and having some fun writing some code. So the Discord link is once again down there.